Welcome to our pre-calculus lesson 26. In this lesson, we will discuss some theories, proofs about quadratic functions, which means there are a couple of formulas we used actually for solving our questions, for solving given equation, given real life problem. And we are interested to know how they are correct, or from where these formulas comes from, or what is the logical basis of those formulas. So mostly that we will try to discuss, try to cover in this lesson. As in, if you look at this, like from where the quadratic formula came, and this quadratic formula, how the discriminant works, this kind of thing. Yeah, this kind of thing. All these theories mostly you will see as it develops. So first of all, of our this quadratic formula, there is some formula which is like x equals to plus minus b plus minus the square root of b square minus 4c divided by 2. I said that formula, how this formula came. This is the, of course, this is the vertex form of our quadratic equation, quadratic function, and from the vertex form we can actually find out the x value, x intercepts, where the function will intersect with the x-axis. We can find it out from here. And this is how it works. Let me explain this little bit this way. We are interested to find out the x-intercept. That means we will write fx equals to 0. This is the quadratic form, so we will write fx equals to 0. That's why fx equals to 0 is written here. So if we write fx equals to 0, this form looks like this. Now you see this k, we are interested in what? First let me clear it up. We are interested to find out this x equals to what? This is our target. X equals to what from this equation now. So to find out x, what we have to do? To find out x, a into x minus h whole square plus k. We have to first send this k to the other side. Then there is some a here. Divide this a. So we have to send it to the other side, so that we are trying to get our x free from all this thing. Then it becomes k divided by a. Then we have x minus h whole squared equals to minus k divided by a. And then when this square will go to the other side, it will give us square root of plus minus square root of minus k by a. Okay. Then we get x equals to x minus h equals to this thing. Now we can actually send this h also to the other side. If we send this h to the other side, it will become h will come here. This h will go to here. This is negative, so when it goes to the other side, it will become positive. So it becomes h plus minus square root of minus k divided by a. That means for this plus, we will get one answer. For plus, we will get the one answer. And for minus, we will get the other answer. So there is two answers coming for the x. And we know that actually because this is a quadratic function. So maximum possibility is there will be two roots of this equation, two intercepts of this equation. Maximum possibility is that. Of course, it is possible that one x-intercepts also we may get, and in some cases no x-intercepts also we may get. But maximum is two x-intercepts, which we get from here. So these are actually x-intercepts. And how it is useful? For example, how it is useful? Why we are doing this? The reason is, if our function is given in the vertex form, then actually we can use this value of k and h and a. Just we can put it here directly, and we can find out the x-intercepts of this function. Now you will say, sir, actually we did not use it in many maths. This is not that much used rule or formulas. Yeah, and I will agree with that. That's correct. That's actually correct. We used it very less, this formula, this form. And the reason is, in most cases, our question was not given like this. Question was given like this: ax squared plus bx plus c. Which is why the formula which is coming here is very important. Let's look at this. But this is also a form. This is also a rule if the function is given in vertex form. Let's recap what we have done here. So we tried to find out the x value by putting fx equals to 0. Okay. So let's look at what happens. And this is an example to find out the x-intercepts. Now look at this side. So say fx equals to x squared plus bx plus c is given. You see, this is the target out. This is our target. You have seen this formula a lot. X equals to minus b plus minus a squared to b squared minus 4ac divided twice. You have seen this formula a lot. And what we do with this formula, we find out the x-intercepts by using this formula. Now see how this formula comes. First of all, just let's be clear about our target. What is our target here? Our target is to find out the x value. X equals to what? X equals to what? And why we have written this value equal to 0? Why we have written this equals to 0? Because to find out x-intercept, we have to write y equal to 0. Y means fx. This equals to 0. Now you see, we will try to free this x square. So to free this x square, we have to divide everything by a. This divided by a, this divided by a, this divided by a, and this 0 divided by a. And 0 divided by a means 0. This is 0. Then a cancel out, so we have x square, b by a, then x, then c by a, then c by a. This is how we get this line. Now how we get this line and why we are going for this line. See, there is something interesting here. We are actually trying to make our formula a square plus twice ab plus b square formula here. And this is x square, already we have x square. Then we can see b by ax. That means, let me write the formula here. A squared plus 2a b plus b squared. This equals to a plus b whole square. This is a algebraic identity, very famous algebraic identity, this one. It means actually it means a plus b into a plus b. If you multiply a plus b and a plus b, you will get this. Basically it means that. Now we are trying to, because it is x square, so b by ax, so it looks like we can actually go somewhat this kind of formula, because see, this is a square and then a square and a, x square and x, they are matching. To get that formula, we need 2 here. We need 2ab. We need 2 here. But there is no 2 here. So, to give a 2 here, you have to divide by 2 also. So, 2 and 2 cancel out. Now it looks like a formula. That's why here you can see b divided by twice a. B divided by twice a came here. B divided by twice a. This term we gave extra. This is not given here. This term we gave extra here. That's why we again subtracted this b divided by twice a whole squared. You can say, sir, why we are doing this mess? Because we are going to get this formula. We are going to get this formula. That's why we have to go through some hard work to go there. So we are trying to make this formula, and then when we write it this way, then basically it looks like a square plus 2ab plus b square. This is b by twice a is b square, which means a plus b whole square. How we can do this? The rule is, if in any algebraic expression, if you add something extra, you have to subtract it from there. That's why we have added this thing extra, and we have to subtract the same thing from the function, from the equation. And why we needed this extra thing? Because we wanted to make a formula, a plus b whole square formula. That's why. So from this part, we get this a plus b whole square formula. And from this part, see, this is c divided by a, this is b divided by 2a whole square. So it means what? it is b squared, and this is 2a whole square, that means 4a squared. That means 4a squared. Now you can say, sir, this was c divided by a, but there are a lot of things here. How can we get that? We are trying to see, we have 2a whole square, that means 4a square, this term 4a square. Since we are interested to make some common denominator, which is 4a square here, so we are trying to make 4a square here. To make 4a square, we multiplied up and down by 4a. 4a, then 4a. If you multiply up and down by same number, then we get 4ac divided by 4a square. So that we can write this line. We can write this line. 4a square is common in the denominator downside. Let me show you here this thing. So this is 4a squared divided by 4ac minus b squared. Okay, and this is in the left side of the equation. When this became, you see, this is b square. This b square is negative, but this b square become positive here because we change this to this side, so it become positive. And 4ac, this was positive, and this became negative because we changed this the whole thing in the other side. Now you can ask me one very important but silly looking question: why we are not changing 4a square sign? Because when you send something from one side to the other side, you need to change the sign of the numerator or the denominator, any one of them. Okay, not the both. If we change the sign of both, then basically we are not changing the sign, because we can then negative, then it becomes positive. Then we are not changing the sign. Anyway, so what happened here? Let's look at this. What happened here? Do you see, we actually have done a very important task, and that is we separated x from everything. In this line actually we have done that thing. See, separated x. This x is separate. X is only here. There is no x here, there is no x here. So we separated x. That's why we have done all this work to separate this x. That's why we have to make this formula and go through this. And why we have to separate this x? So that at the end we get x equals to something. Our target is that. And here also our target was that. X equals to what? We are trying to find it out. So we separated x, then you can see this is whole square. So when whole square goes to the other side, we get plus minus a square root, pretty much the normal thing. Then this is b by twice a. When you send it to the other side, it becomes minus b by twice a. And this is square root of 4a square. So square root of 4 means 2. A square is square root means a. Now you can see this is twice a, this is twice a, same. So we can take it common denominator. So we can actually take this common twice a. Then we have minus b here. Then plus minus square root of b square minus 4ac. So we every now and then we just use this formula directly instead of going through all this complication. Okay, so this is how actually this formula came, and this formula is very old. Actually, this formula is very old. This is one of the oldest formula actually. We can say that we use still now, and still it is working fine. How old is this formula? Probably about 4,000 years. This formula is about 4,000 years old. We can check it if we to be precise, but of course we will not know for sure. Anyway, so this is how we know x equals to minus. But hey, there is another interesting thing. Actually, there is 1-2 years back there is another proof of quadratic function, this kind of quadratic function. There is another formula came, but that formula is not still popular. But this one is really used everywhere. I mean, widely used, and globally everyone knows this formula. So this is how this formula came. Let's move on. This formula, what it does? This formula, we get x-intercepts from this formula. X-intercepts, or the solution of the function. Solution of the function means x-intercepts. And similar math, similar math you will see in the book 139 number page. And we use this formula, how we use this, and from this b square minus 4ac, actually we can decide a couple of things, which is how many solution we will get. If this value is more than 0, then we will get 2 answer, and if this value is equal to 0, then we will get 1 answer. You can actually see it here, because if this value is more than 0 means what? Suppose it is 2, suppose it is 5, suppose it is 6, then there is 2 answer. Why the 2 answer? Because for plus 1 answer, for minus 1 answer. That's why there is 2 answer. There is 2 x-intercepts. Now if this value is 0, why there is only 1 answer? Because at that time this is 0. That's why this plus minus 0 do not have any value. It doesn't matter. Okay. So only minus b by twice is the answer at that time when this equal to 0. And if this value is less than 0, which means if this value is negative, at that time no real solution. That's why we do not have any x-intercepts at that time. We already said why. And this is the example. Actually you have seen this example in our previous some slides also. And these are some solutions which you have seen also. I think this value will be positive, I guess. Yeah, we have done some correction about this. This is minus 4 comma, we can check it. I think this value will be positive. 4x squared, let me check. 4x squared plus 5x minus 3, so minus 1.693. Ouch. Shift TNG. Okay, then let's check the other value, minus 0.003. Yeah, so it should be positive, I guess. Let's put positive plus 0.443. Yeah, this should be positive. That's true. So this value should be positive. Let me edit this. Let me edit this. This value is positive. Okay. So this value is positive. We have to use this formula to find out answer of that question. To find the answer of this question, we have to use this formula, Now come to the another formula, which is, we used many times actually to find out the vertex. We always said, okay, let's use minus b by twice a formula and put it back. So how that formula came? See this is here. So you know that our vertex form of the quadratic equation, which is here actually, we can keep it here. Okay, which is here, a into x minus h whole square plus k. So suppose, for example, let's say this is given. Suppose this is given, ax square plus bx plus c, which there could be number a, b, c. They can be some number. Okay. First of all, our target is to free this x square. So there is a. So let's take this a common, so that there is no a with the x square. So x square is free. But if you take this a common, there is no a here. That means you have to give another a down, so that this a and this a cancel out. We get bx again. C is a constant term, so let's not disturb this c, because c is a very good and gentle person. So let's keep it somewhere else. We are not disturbing c. We are just interested about this x squared plus bx. Now this is x squared. We are interested to make that formula, a plus b whole square formula, and similar for the same or similar rule. See, this is, we can make this formula, a square plus 2ab, this a is x is a, this term will become b. But you see, if we give here 2, then we have to give another 2 here, because in this main question there is no 2 there. There is no extra 2 there anywhere. So that this 2 cancel out, we get this b by a x. This may seem little bit unusual. Why we are giving extra 2? Where we are taking the then again taking it back? This is to match the formula. Sometimes to match the formula, we have to give something extra from us, and then again we have to cancel it out, so that there is no problem in the logical fallacy, logical problem in the solution process. That's why we give them. Ouch. Yeah, that's why we give them. So what happens if we give this 2? This 2 is for the formula, but when you give this 2, we have to give another 2 down. Then this down number becomes b divided by twice a. This extra number becomes b divided by twice a, b divided by twice a, b divided by twice a. Let me write it here. Let me write it here. So what happened here is x squared. I have to take it. So this is x squared, and this term is, see, 2 a already x. We know that a is x because this is the x, a square, a square plus 2ab plus b square formula. So x is a. The b is what? So b is b divided by twice a. Then plus b square. So we know that this whole thing is b. So plus b square means b divided by twice a whole square. B divided by twice a whole square. And so you see, b divided by twice a, from where this twice a came again? There was b divided by a. To match with the formula, we have to give this 2. Again, since we have given this 2, just for the formula to match it, we have to take it back. Now we cannot take it back from x, because x already we can see this is a. So there is some customization possible in the b divided by a. So we can give this 2 here, so that this 2 and this 2 is cancel out, and then this entire number becomes b, this entire, and this is b square. So b by 2a whole square, that means b square, 2a whole square means 2 square means 4, a square means a square, so 4a square. That's why 4a square came, b square by 4a square came. And see, once again the same rule. This is the creepiest line here. Once again the same rule. This b square minus 4a square is also not given in this line. So we have to cancel it out. And when we cancel it out, you see there is another extra a outside the bracket. So we have to multiply it here also. So basically you have to subtract this entire thing, because this entire thing is extra here. It is not given in this place. And why we are doing all this work? The reason is we are trying to make this nice little formula. So we have a here, this a, then a square plus 2ab plus b square. We already said that our b means this value. B is this part. This part. That's why we have a, then plus b square. A plus b. B means b by twice a whole square. A plus b whole square. A plus b whole square. The same formula that we said in the previous page. Yeah. Then we have c divided by c. Then see, there is a here and there is 2 a's here. So a cancel out. There will be another extra a here. So we have the remaining is b square divided by 4a. And if we do some LCM here, then it becomes 4ac, 4a into c. So 4ac minus b square divided by 4a. So we have this format, a into x plus something, etc., etc. We have this thing. Now see what actually we have done technically here. What we have done here is, if you look at this, just keeping an eye with our vertex form. Vertex form is a into x minus h. So this is x minus h whole square plus k. That means our h value is b by twice a, but there is a minus here, so minus b by twice a. So h is minus b by twice a. That means vertex h value is minus b by twice a from this format, minus b by twice a. So vertex x value is minus b by twice a. H comma k is the vertex, so we can say h also. X value of the vertex in any ordered pair, there is two answer. One is x comma y. So x value is minus b by twice a, and k value is actually 4ac minus b square divided by 4a. But we do not use this formula also a lot, because when we find out minus b by twice a, we put it back in the question, then we get the y value, which is easier. That's why we always go for that. Now you will say there is like, oh my god, this is some kind of messed up work, why we have to do all these things. And this is true, you are right about that. That's why we do not go for all this formula, all this rule in every math. We just directly go for that. We look at this kind of form, and then just we directly go and use this formula to find out our solution, to find out our answer. But we can actually do this entire operation for all the maths if necessary, or if we are interested. Actually, this is possible to convert any of the quadratic functions to this format and find out h value and k value, which is vertex of the quadratic function. We can do it this way also, which will definitely take more time. But do you know, this kind of thing is, when you understand all this thing inside the story of the maths, then actually you will feel good and your understanding will be more solid. So that's a good thing. So this is how the vertex thing actually came. Yeah, so you will see that suppose this is x squared minus 7x plus 6, and we use minus b by twice a formula, we get this 3.5. We then put 3.5 back in the question, we get the answer. So easy. See, that's why those who find out this formula, we respect them so much. These people, because they make it so easy for us. Yeah. This is completing the square. Actually, you have seen this slide, but we like it. We liked it so much. That's why we are showing it again and again. This is x squared plus 4x plus 10. If we want to transform it to our vertex form, see what we have to do. So there is 2ab. Again, we have to match 2a, b. Then we have to give 2 square, because b is the 2. Then this plus 10. Now see, we have given this extra 2 square here. So let's subtract this 2 square from here. Now you are seeing something interesting. See, similar pattern actually we are following. But here we did not bring any 2 from ourselves. That's why we do not have to divide anything. Why? The reason is there is a 4 here. So this is a good news for us, because 4 we can separate this 4. We can break this 4 2 into 2. We can break it up. That's why we do not have to bring anything extra here. Suppose 6 is given, so you can write 2 into 3. 8 is given, 2 into 4. Or 10 is given, 2 into 5. We can break it down. But when some odd number is given, then you have to start thinking again about this. How can we match it? How can we match it? How can we make this a square plus 2ab plus b square, or a square minus 2ab plus b square in cases? So we have this, and this, see, now we have only extra thing that we have written here is this thing. That's why we have to subtract it from here. So ultimately we have here, this is a square plus 2ab plus b square. That means this side is a plus b whole square. A plus b whole square. Then this is 10 minus 2 square. 10 minus 2 square means 10 minus 4. 10 minus 4 means 6. That means it is plus 6. Then equal to 0 or something, some other things. This is how you will see that in the solution. You will see that line. That's why I have done it. And how it happens. See this twice x, twice x. This 4x, we can break it twice x and twice x. This is how we get the whole square thing. See? So this thing is whole square. This thing x plus 2 whole square. X plus 2 whole square. Then this is the plus 6. This is the plus 6. Some of the thing, there was 10 here. Some of the thing you have to separate and bring it here to make it look like a nice little square. This is 2. Then see, x plus 2. This x plus 2. X plus 2 this side. X plus 2 this side. So x plus 2 into x plus 2. That means x plus 2 whole square. Then plus 6. This x plus 2 whole square plus 6. So this is how we can convert it to vertex form. This is another important thing. Remember, in today's quiz also, I hope that you solved it, or maybe you skipped it if you have solved the other maths already. I mean, since there was option. So, but as at least you have seen that math where we said that find out for what value of W or L we will get the maximum area. Then we have found only the length, or W. Suppose in some math we have found L equal to 150 or W equal to 150, that kind of maths. And only we tried to find out let's keep it here. Only we tried to find out the length or width, only one thing. But the question was, there is two things. The question actually asked us two things. One is length and W, length and width. So both of the things question actually asked us. And our question was, what value of L or W will maximize the area? That was the question. So we said we have found just one value. We said that length equal to this or W equals to this will maximize the area. In that math we have found it. Our question is why just one value is enough, or how that value actually maximizes the area. Remember, let me remove everything from here. Remember, in that math perimeter was given. We said that AW wants to do some tree plantation, and there is like 10 meter apart there will be trees, and we want 40 trees in some case, 60 trees in some case, 80 trees, etc. We said that the perimeter will be 800, 600 or 400, whatever it is. So perimeter is given. Okay, perimeter is given. Now think about a math where the perimeter is given. Let's say we have actually the rectangle here. Sorry, here we actually have the rectangle here. Let's draw one rectangle from here. So suppose we are saying that this is a rectangle where this side is 2, this side is 2. We want to make, first our target is, suppose our perimeter is 16. So how can we construct it? So one way we can construct it is, we can write here 2, so 2 plus 2 is 4, 2 plus 2 is 4, so then we need 6 and 6, so 6 here, 6 here. This way we can construct, and then we can construct it like this also. Our target is total will be 16. So you see, 2 plus 6 means 8, 8 plus 2 means 10, 10 plus 6 means 16. Our target is total 16. Then another combination is possible. We can make this like this also. We can make this figure 3 and 3. 3, 3, 6, then 5 and 5. This is also possible. This is also 16. Then we can make it like this also. We can make it like this also, where we will write everywhere 4, 4, 4, 4, 4. This is also total is 16. Total is 16. Now our question is, where is the maximum area? Which figure is the maximum area? Which figure is the maximum area? That is our question. Okay. So this area is what? Area means length into breadth, or length into width, whatever you say. So 6 into 2, that means area is 12. Area is 12 here. What is the area here? 5 into 3, that means 15. What is the area here? 4 into 4. That means 16. Now think about it. Is there any other way possible we can make 16 our perimeter? Suppose 16 our perimeter, like total will be 16 and the total will be 16 and any other combination possible. Suppose if you write 7 and 7, what it becomes? 7, 7, another combination is 7, 7, 7, 7. So we can write here 7 and 7. So 7 and 7 means total is 14, and we can give here 1 and 1, total is 16. So what is the area here? What is the area here? Total area is here. 7 into 1 is 7. So what is happening here? Basically, you see, where is the maximum area? Which figure is the maximum area? You will notice that our maximum area is this figure. Maximum area is this figure. And maximum area we get when length width both is same value. This is 4 and this is 4. Both is same value. Then we get the maximum area. When the perimeter, some perimeter is fixed, then we have to make it square. Then you will get the maximum area. All other combination will give you that some minimum area. And what is happening here is, this is 4. So you go up by 2 and you go down by 2. See? 4 plus 2 equal to 6 and 4 minus 2 equals to 2. Here you go 1 up, that means 4 plus 1, you go 1 up, then 4 minus 1, you go 1 down. Here you go 3 up, 4 plus 3 equal to 7, 4 minus 3 equals to 1. Whatever you do, it doesn't matter. All of your value is less, less, less. You get less, less, less area everywhere. This is very interesting proof actually. How can you maximize the area of a rectangle? And answer is, you have to make it a square. You have to make it a square. You have to try to make it a square. When the perimeter. Now you can say, sir, okay, I can draw another. Suppose let me show you one very discrete, separate logic or anti-logic. You can say, sir, I can write here. Suppose I will write here. This is 6. This is 6. Sir, I will write here 3. What you will do? 6, 6. So area is bigger, right here. 6 into 3 means 18. Yeah, that is 18, but the perimeter is also more. Perimeter is not 16 now, because our main condition is perimeter. For a fixed perimeter, what type of figure gives us the maximum area? Here the perimeter is what? 6 plus 3, 18. Perimeter came 18 here. So it is more. Perimeter is already more. So basically our condition is violated. So that's why they do not work. So when it will work only when it is square. If it is not square, if it is rectangle, then basically you are making it lower and lower and lower. That's why in that math related to W and L in our practice class also, revision class also, during the revision class we already tried to find out one value, either L or either W. One value is enough because both will be actually the same value. If you just find out the value of L, this will be the value of W also, because they will make the maximize the area. They will make the area maximum, and that is only there is one answer. There is no two answer. Although it is said that find the length and width, find L and W, or find M and N, both find. But actually both value is same, because when it is same, then we get the maximum area. So this math is super interesting actually when you look at it, and this is the theory here. Basically you get the maximum area, suppose x into x. When you write x into x, this is x squared. But when you add something with the x, like our 4, we added, suppose it is 4 and 4. So when you increase something this side, something you have to decrease from the other side. You know that. Suppose 4 plus 2, 6, and then 4 minus 2, then 2. Your perimeter is same, Perimeter is same. But what happens when you do that? If you try to find out the area, basically your area becomes x square minus a square. This area is x square and this area is x square minus a square. That means from x square, here you are subtracting something. That means you are taking away something more. That means this area will be less. This area will be less because suppose this area is 10, this is 10 and you are taking something from that 10. That means this area will be less and this area will be more. How this is a proof actually. This is a proof. You have to increase something with the x and you have to decrease something. Why you have to increase and decrease? To make the perimeter same. Because our condition is for the same perimeter, how we get the maximum area. So the maximum area will be when it is square. But if you increase one side, you have to decrease the same value in the other side. Then if you multiply them to get the area, then basically your value will be less. And by what? By the amount that you increase or decrease. That value is squared. That much you will always lose if you do it. Okay. So this is actually an interesting application, interesting thing about this area. If you have planned to make your home and other things which is square feet is related, square feet is important, you need to take care of this kind of figure. Yeah, you may need to apply it in your real life situation also, because you need to understand what type of figure, what type of shape will give you maximum square feet so that you can sell it to get the bigger money. Yeah, so there you can use this kind of math. And that's the end of our today's slides. You can try to practice. The required reading is this page, which is related to quadratic inequalities. We will start that these sections in our next week. We will start this, and just for practice, you can try to make this into Vertex form. Just transform. You can try to transform it to Vertex form. And that's all for today. Thank you all. Thank you very much. Have a wonderful time ahead. Bye bye.